Hey folks, my name is Peter Zaitsev, and I'm going to talk to you about the hybrid cloud and how you can use Kubernetes to build the truly open source cloud native database as a service solution. Let me start by talking about my perspective, because I think that's very important as it influences the whole rest of the presentation. I am somebody who was involved in open source database for rather a long time. Oh my gosh, it's like more 25 years right now. I was one of the early staff members of MySQL AB. That's before it was Oracle company, even before Sun. I was founder and CEO at Percona for many years, and now I act in different capacities, working with a lot of open source focused businesses, and in general advocate for open source. In my opinion, everything being equal, the open source solutions are better from lots of different reasons, ranging from the cost, but most importantly, of also in terms of allowing you to avoid vendor lock-in, and in terms of freedom, right? And freedom to innovate, freedom to use the software as you like, and so on and so forth, right? And what that means is for all of us, I think, in this ecosystem, it makes sense to invest our time, our money, and our resources in making open source software better, because that is how all of us benefits, versus if you are investing with your patronage to the proprietary software vendors, then guess what, right? They just, that's their employees, their shareholders would be the first one to benefit. And yes, maybe they're going to use that money to be a better process, better software, and then use that to turn around to you and say, hey, software is more awesome now. Why don't you pay us more money for that? Okay. Now let's get talking about specific this presentation. So we talk about the hybrid cloud, right? What exactly is that? We talk about hybrid cloud when we are having some sort of on-prem infrastructure, or maybe private cloud plus public cloud infrastructure. And then there is also a related term which is being used a lot, is called multi-cloud. That is when you are using multiple public clouds, right? Now, if you think about that, in a lot of cases, those kind of multi-cloud and hybrid cloud, they're kind of variations of their, like, a very similar thing, right? Because this is where we are using cloud technologies, but they have to use them in a different way, right? Not only as a single vendor has them. Now, what is interesting about the hybrid cloud is something which is rather common. If you look at the Gartner stats, they believe more than 70% of the large organizations, which Gartner deals with, are using hybrid cloud right now, and in a few years that's more than 90%, right? So I think what understanding hybrid cloud and multi-cloud environments is very important, because, well, that is becoming very much ubiquitous and continues to grow. Now, if you think about the public cloud as our kind of solution there for our platform, the cornerstone, I think it's very interesting what trade-off it gives us, right? It gives us a lot of convenience, right? If you think about the AWS, GCP, Azure, right, you can say, hey, we have a lot of services here which can be rather polished, well integrated, and so on and so forth. But that comes with a vendor lock-in, because the more you use of that really kind of proprietary convenience when those cloud vendors offers, the harder it is to move if you were to need that. Now, if you think about the hybrid and multi-cloud, the trade-off that gives us Well, less convenience because things are kind of more tricky if you are using multiple clouds. And yes, even if you're using some sort of like a multi-cloud control plane, it's still going to be sort of like a less advanced. You have to like give up some features which are specific for a given cloud. But that comes to us with a less vendor lock-in. And I think that is a very important trade-off to consider. When we see organizations looking for the hybrid cloud, you can think about that from two different strategies. One of that is portability, right? Basically lock-in avoidance, right? Or maybe in some cases that portability may be required. For example, if you are some multinational company and you want to operate in different countries, there may be certain restrictions about where you store certain kinds of data, right? And that's maybe only allowed to store in a local data center or stuff like that. Then another approach is using cloud for best features or best pricing. This is very common, for example, in data analytics or AI standpoint. We can say, hey, whoever has a ability to, let's say, process our data in the best way possible at the lowest price, then that is what we are going to use, right? And that may not be the same as a main cloud where your or main service where your data operates. So if you think about how can we approach the hybrid clouds with an open source lens, which I already disclosed I love so much. What we can do in this case is to use the cloud to provide us with commodity infrastructure. And I mean things like storage, compute, networking, GPUs increasingly. And then we can build the high-level abstractions and get the high-level value through the open source software. And this is where I think CNCF or Cloud Native Computing Foundation becomes very important. This association really has grown to include so much different components and different solutions, right? We really cover almost everything you need, and that landscape, which I'm kind of showing here, continues to grow. If you are looking to approach your infrastructure in a cloud native ways, well, you are going to probably to look at Kubernetes. And Kubernetes, I think, is awesome because this is your, control plane, workload scheduler, right? Which is very, very ubiquitous, right? It obviously can run at any clouds, any data center, right? Many clouds offer you the managed Kubernetes solutions. You can spin it on your laptop, right? And it can be found in many like other unlikely places, right? For example, there are some installations of a Kubernetes in the space, underwater, on moving vehicles, and so on and so forth. I think what is also very cool with Kubernetes and a lot of that cloud native ecosystems, it works very good with GitOps rather than a ClickOps, which I think is a much more modern, reliable approach, right? And I think it also works very well in a new age when we're speaking about our architecture and our applications created by agents, not just people. In this case, rather than something get a few buttons or call a few API calls, it becomes kind of much harder to control and reason about compared to saying, hey, we have a declarative version infrastructure as a code in our repository, which makes very easy to reason about, track the changes and so on and so forth. Now, we are talking about database, of course, here. And the question with databases often arises is, can you actually run database on Kubernetes, or should you, right? And what people often say in this case, saying, well, but you know what, the Kubernetes was designed for stateless applications, right? Well, and yes, that is the case, but I think what the thing was originally designed for may not be always the same what that's exactly was found its most common use for. I mean, some of you may know what Viagra was designed as a heart medication, but that's not how it's used, right? And Kubernetes is kind of the same. So if we speak about stateless application and a data application about on Kubernetes, there is a lot of work which is done about the running data intensive applications on Kubernetes. For example, there is a whole dedicated community called DOK, Data on Kubernetes, right, which includes a lot of end users, companies which are building applications in this case. And here are some stats from one of their recent DOK days. They shared results from CNCF poll of their users, and we can see what a lot more people those days believe what Kubernetes is ready for stateful workloads, and that includes databases, and actually a whole 70% are running some of those workloads in production. And I usually, when I have a chance to do a similar talk in the room, would first ask a pool of hands and then present those numbers. The database guys are kind of often very conservative, right? And you would have probably, less than a half room thinking the database are ready for Kubernetes, right? So I think that is a stats is very relevant. What comparing to showing how many people are actually successful in doing that. Now let's also highlight what Kubernetes actually powers many database as a service solutions out there, right? So it can be, can be configured to run the databases reliably. I would say though is what in many cases Kubernetes requires some, special configuration, all right, to be working well with databases, right? It's not what you take the, random Kubernetes cluster, just deploy some random operator without no configuration, and that will work as awesome as some managed database service for you. That is not the case, but you can make it work. And for that, of course, you need to follow some best practices, and that is what I am going to talk about next. The first thing what I would suggest in Kubernetes is to make sure what you are using Kubernetes operator for production. Kubernetes allows you to also just to take and deploy standalone Docker container. But if you have something more than a test and dev, if you're looking for production, you are looking to you should be looking at the operators instead of that, because they typically automate many of the day two operations, which are very important for many databases, right? Things like scaling, backups, maybe healing in case of failure, and so on, and so forth, upgrades, and so on and so forth, right? The next one is also kind of pretty obvious. You want to set up high availability, right? Because depending on a single environment in Kubernetes is not a good idea, because it's even less reliable compared to let's say your bare metal, even virtualized environment, for the variety of reasons. The third one to mention would be to use persistent volumes, right, where we are using as a local disk or fast remote storage to store your data, which is very important, because if you don't, you may just lose your data. If you are using operators, they are likely to default and enforce here, right? Which is another good reason to use them, because operators can sort of opinionatedly enforce, or at least enable by default, some of the best practices. The next one is think about the data. How much data do you have per pod? Often, again, because of the ways Kubernetes works, network, backups, provisioning, and so on and so forth, typically it is not very good to have a huge amount of data per pod, right? I've seen people successful with maybe, terabytes sized pod instances about when it comes to the data size, right? But if you think about going to tens of terabytes, right, or more, that is likely to be problematic. Again, not in terms of what feel like a break or stop work, and it's even maybe performing well, but it is a question of doing various maintenance operations, and in Kubernetes at that scale can be problematic. The next thought would be to use nodes of their appropriate size. A lot of Kubernetes installations may be developed, deployed using relatively small node sizes, right? And just, number of them. When it comes to their databases, you often need their larger nodes, just because, well, databases generally perform well if you're having some large instance sizes, right? And that is means, or in certain cases, people would use a dedicated fleet of nodes or something to deploy their high performance databases on Kubernetes. We also want to make sure to configure resource and limits, which may not be there by default. In many production databases, we actually prefer setting resource equals to limit, which is kind of a special configuration for Kubernetes. Gives you guaranteed quality of service, saying, hey, you know what? Yes, you're not going to be able to burst more when requested, but you're also not going to get less CPU or less memory compared to what you expected. The other little trick when it comes to Kubernetes is to make sure you are using proper anti-affinity rules, right? Because if you happen to have a highly available Prometheus cluster and you have 3 different database nodes which happen to run on the physical node or maybe on the same rack, that is not going to be a great havability solution, right? You want to really manage that, what havability is provided from, what those different nodes are truly independent. The next one is, of course, you want to tune your database. And I mean both tuning configuration, indexes, set up queries to be good. Kubernetes is not magic in this regard. And if your database was poorly performing because of poor configuration in non-cloud native environment, well, it probably would do the same, and even likely do worse in Kubernetes case. You can use for this the tool Percona monitoring and management, which is Percona's open source solution for database monitoring, right? And it works with many open source databases out there, or you can use the other tools, of course. Next, I would encourage you to think how you're going to scale, especially considering the scaling up by going to like a massive single node is often not very good approach in Kubernetes. Depends on the databases you have. Some databases can be, natively sharded, such as like a MongoDB or ClickHouse, right? There are others may say, well, you know what, you can scale by having the number of read replicas, right? In other cases, maybe that is not how you scale, and the only way is up. I think that is a very good to really understand what is your plan for scaling if you need to, and how to implement that on Kubernetes, so you are not running in any surprises. The next one would be to make sure to adjust the Kubernetes behavior for databases. Like, what is special about a database compared to stateless applications? In stateless applications, many cases you can kill the application, kill a process, and it's boom, right? In maybe a few seconds, or even sometimes milliseconds, the process can respond, the node can respond, boom, and it's operational. When it comes to the databases, right, it often would have to do like a crash recovery. It has to warm up. It has to do some other things. It may take quite a long time for that to reach the peak performance. So you do not want databases to be needlessly disrupted by rescheduling, by some other activities. And that means you want to make sure to set eviction pod priority, right? So databases are not kind of messed with unless absolutely necessary, as well as to work with a post-disruption budget to make sure what the large number of database nodes in your cluster stays up during various Kubernetes nodes upgrades and so on and so forth. You also want to make sure you are not accidentally exposing your data unless you have to, right? That is, I think, a very, very common issue. What databases accidentally gets exposed, it's becomes publicly accessed, and then data leaks or kind of change data and so on and so forth. You do not want to deal with that. You want to be very careful about this issue. We also want to enable encryption. Well, that, I think, is a very easy and clear things to do, right? But it's still often omitted. You want to make sure you encrypt the data at rest, right? That means the data is encryption on disk as well as in transit with something like TLS. What is important in this case, there are some rumors about how expensive encryption is and so on and so forth, right? But a lot of that originates from many years ago, where software and the CPUs have been optimized to handle encryption those days with a very, very low overhead. Another security-related trick is what you want to use Kubernetes secrets as a way to pass the database credentials to your application, right? That is a good kind of secure cloud-native way, instead of hard coding that in a source code, right, or the other tricks like that. And again, you can see number of operators they make that easier to kind of to bridge the gap between Kubernetes secrets and the database users. Backups. Don't forget the backups, even if you're doing the clustering. And I think that is especially important because if you're using some good operators, they're likely to have backup functionality built in. You just have to tell them, I want to do a backup, right? Or even sometimes specify the schedule. Hey, you know what? Operators, please take a backup every day, maintain 7 generations, right? And they're going to do that for you. Another thing to consider is this. While you see a lot of very popular databases, MySQL, Postgres, right, run on Kubernetes, these are something which was not really designed for this environment. They were adapted for it. And that is, I think, where it's very interesting to see what is new coming up. We have solutions like Vitess, Neon, Yugabyte, TiDB, which were like really implemented for this cloud native age. And while they are not as popular yet, I would consider looking at them, especially if you have some needs for very large distributed databases. CPUs. When it comes to the CPUs, I would make sure you look at the whole landscape which exists out there outside of Intel and AMD CPUs, kind of which are very very well known. The ARMs have become very high performant, good CPU choose for many workloads. If your operators and database support it, I would suggest to try it out. The big question when it comes to Kubernetes is also often the Kubernetes deployment mode, which can be managed or by the cloud vendor or self-managed. Both of them have their merits. So they're kind of good for different teams. If you don't have a lot of Kubernetes experience, you often opt out for managed solution. If you say, hey, I want the flexibility and I want absolute control, then self-managed Kubernetes deployment in the cloud is a good use. The next one would be to talk at the utilization. I think what is very interesting in a Kubernetes environment is because it is kind of so dynamic. Often you may find what you have more nodes running the database with a lot of kind of free, sort of like a free space out there, which is not utilized, and that can become expensive, right? So I think that's a good sort of like a FinOps practice in this case to make sure you are watching how your nodes are utilized. And why I speak about that in a database in particular, right, which exists for Kubernetes overall as well, is what Kubernetes are those kind database often are those kind of big blocks. You have this like a big stone which requires a lot of CPU nodes, a lot of gigabytes of memory, right? And then it kind of goes into the node, right? And then no other big stones can fit there anymore, right? And that can get things suboptimal. Now, if you look at what we are doing at Percona in this regard, we are enabling some of the most popular databases to run in the cloud. With MySQL, we have a really enterprise grade, but also open source operators for MySQL, MongoDB, and Postgres. You can check it out. Now, we spoke about the database as a service, right? Well, if you think about the Kubernetes is awesome for some teams at least. Some others would tell, well, you know what? Kubernetes is awesome. It has this day one and day two automation. It reduces the toil, very similar to databases as a service, but UX is kind of different, right? Maybe I'm not somebody who is comfortable doing 100% GitOps yet. Well, in this case, we can actually go beyond the operators, and there are some nice GUI solutions which exist for that. I would highlight here the Open Everest, which is an open source database based on Kubernetes, which is something which was previously known as Percona Everest, and now we have helped to spin it out in their kind of community-run independent project. We focus on supporting a lot of different open source database technologies, not just those what Percona works with. Another thing what I would want to highlight is their observability. If you are looking for operators in particularly, and then databases, they can have a lot of moving parts inside of them, and that is their Karoot is the awesome solution you can check out, which is also the open source solution, which you can play out to understand how different components communicate to each other, and if there's any failures, where do they originate from, right? And that really helps to understand the problems. Also, what you can learn from Karoot is it can help you to be proactive with a lot of risks and anomalies. Like, for example, you remember I mentioned, hey, you guys do not want to accidentally expose some of your critical services. Well, that is something what Karoot watches you, right? Watches, and it will flag, hey, this stuff is not highly available, and hey, you are potentially needlessly exposing that service, and you should not have to. Well, with that, that's all I have. I hope that was a helpful high-level overview of what you can do with a Kubernetes in a hybrid cloud and some of the best practices. Thank you.